Hello students, in today's lecture we are going to solve some questions based on electric charges and fields, and this is NCERT Examplar. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So, our first question is, in figure, two positive charges Q2 and Q3 fixed along y-axis. Look at here, Q2 and Q3 exert a net electric force in x direction. Electric force exert in x direction on charge Q1 fixed along the x-axis. If a positive charge Q is added at x0, here positive charge is added, capital Q, the force on Q1 is what? So in this question we have to find out the force on charge Q1. The given options: option A is shall increase along the positive x-axis, option B shall decrease along the positive x-axis, option C shall point along the negative x-axis, and option D shall increase but the direction changes because of the intersection of Q with Q2 and Q3. So which one is correct? Please think about this. So our correct answer is A, shall increase along the positive x-axis. Solution. So the procedure to solve this type of question is, first you need to find out the nature of the force between Q1 and Q2 and Q1 and Q3. Nature of the force will give you type of charge, positive charge, negative charge. So by finding the nature of the force, you will be get type of charge. After that, find the nature of force between newly induced charge and charge Q1. So here the newly added charge is which one? This. Yes or no? Capital Q is the newly charge. So the important point here is this: like charges are repel, whereas unlike charges are attract to each other. So we will use this concept to solve this question. Clear? So our answer is, look at here, according to question, Q2 and Q3 are situated on y-axis. So the net force on charge Q1 due to Q2 and Q3, net force on Q1 by Q2 and Q3 along x direction is what? So here the nature of the Q2 and Q3 is positive. Q2 and Q3 is positive charge. It means they attract Q1. It means the nature of the charge Q1 is negative. So nature of the force between Q1 and Q2 and Q1 and Q3 is attractive. Q1 and Q2 and Q1 and Q3 attractive. Why? Why they are attractive? Because like charges repel each other, or unlike charges attract each other. So here Q1 and Q2 are unlike charges. Yes or no? Similarly, Q1 and Q3 are unlike charges. So they attract to each other. This can be represented by the figure, this one. So the force of attraction and between Q1 and Q2 is attractive, having attractive nature. So next is the attractive force between these charges states that Q1 is negative charge since Q2 and Q3 is positive, because both are attracted to each other. Similarly, Q1, Q3. The nature of the force between Q1 and newly introduced charge Q, this one, is positive, is attractive, and the net force on Q1 by Q2 and net force on by Q2 and Q3 and Q along the same direction as given in the figure, this one, in same direction, or we can say in along positive x-axis. This is clear? So solution, here the given figure clearly shows that the force on Q1 shall increases along positive x-axis due to positive charge Q. So the newly add charge Q and the charge Q1, both the nature is what? Attractive or repulsive? The nature is attractive, and the direction of Q is along x-axis. Next question. A point positive charge is brought near an isolated conducting sphere. Look at figure. A point positive charge, Q is a positive point charge, and this brought near a isolated sphere. The sphere is isolated. The electric field is best given by what? So here you have to find out the representation of electric field. So which one is the correct representation? Option A, option B, option C, or option D? How we can solve this question? Think about it. So correct option is A. Solution. So our thinking process, when a positive point charge is brought, look at here, the charge is positive. When a positive point charge is brought near a neutral conducting sphere, charges are induced in sphere through electrostatic induction. So here electric field lines follow some rules. So answer is, when a positive point charge is brought near an isolated conducting sphere without touching the sphere, then the free electrons in the sphere are attracted towards the positive charge. So this leaves excess of positive charge on right side, or we can say right of the sphere in this direction. So next, so the correct representation is this one. Both kind of charges are bound in metal sphere and cannot escape. So they therefore resides on the surface. Look at here. An isolated conducting sphere consists of both positive and negative charges. Yes or no? So when a positive charge is brought near the conducting sphere, so in that case the negative charge are moved towards the positive charge. Thus the left therefore they reside on the surface. Thus the left surface of the sphere has an excess of negative charge and right surface of the sphere has one positive charge. Right side positive charge and left side negative charge. So electric field lines start from positive charge and ends at negative charge. So positive charge to negative charge. So also electric field line emerge from positive charge in case single charge and ends at infinity. Here the correct option is A, that fulfilled all these conditions. So if we talk about the option B, the electric field lines in option B do not correctly represent the distribution of charge on the sphere. The lines should start from positive charge and end on negative charge induced on the sphere. So this is not correct. If we talk about the option C, electric field lines should not be perpendicular to surface of the conductor. Thus, according to the third figure, it is also wrong. And if we talk about the option D, electric field lines should be perpendicular to the surface of the conductor. Thus, according to the third figure, it is also wrong. So, direction of electric field is also wrong in the option D. So, only which option is correct? A. Clear? The electric flux through the surface is what? So there is some figures, a first, second, third and fourth. You have to find out the electric flux through the figure. So in figure 4 is the largest electric flux. Option B, in figure 3rd is the least electric flux, and option C, in figure 2nd is same as figure 3rd but smaller than figure 4, and option D is same for all the figures. So which one is correct? Which figure is correct? Think about it. So here electric flux is what? Electric flux is equal to, according to Gauss theorem, phi is equal to Q enclosed divided by epsilon naught. It means total charge enclosed by the closed surface divided by epsilon naught. Yes or no? So here flux is independent on the surface because it does not depend on shape and size. So which one is correct? D. Clear? So correct answer is D, is same for all figures. Solution. So Gauss's law of electrostatics states that total electric flux out of a closed surface is equal to enclosed charge divided by permittivity. So total enclosed charge is Q enclosed and permittivity is epsilon naught. So phi equal to Q divided by epsilon naught. Therefore, total electric flux through a closed surface is independent of the surface shape, size or area, but depends only on enclosed charge. In this question, all figures have same electric flux because each encloses a single positive charge. So there is a only single positive charge. There is a only single positive charge. In figure 3rd, there is a only single positive charge. In figure 4th, there is a only single positive charge. It means the electric flux depends on the only charge. So total charge is Q divided by epsilon naught in all cases. So flux is same for all the figures. Clear? Five charges Q1, Q2, Q3 and Q4 and Q5 are fixed at their positions as shown in the figure. Look at figure. These are 5 charges. S is a Gaussian surface. The Gauss's law is given by integral E dot ds is equal to Q divided by epsilon naught. This is Gauss law. Which of the following statement is correct? Please answer. Which one is correct? Option A, option B, option C or option D? Think about it. So according to Gauss law, total flux is equal to total charge enclosed by the closed surface divided by epsilon naught. So this is the Gauss theorem. So our correct answer is B. E on LHS means this one. E on LHS of the above equation will have a contribution from all charges, while Q on RHS, that is Q divided by epsilon naught, will have a contribution from Q2 and Q3, because in figure there is only 2 charges, Q2 and Q3, that is enclosed. So according to Gauss theorem, total charge enclosed by the closed surface divided by epsilon naught is equal to total flux. So solution. According to Gauss law, from in term Q, on the right side of the equation, integral S, E dot ds is equal to Q divided by epsilon naught, includes the sum of all charges enclosed by the surface. So that is Q2 divided by Q3 only. One question for you. So suppose there is a one more charge and we here consider Q6. In that case, what will be the answer? Please answer. Or we can say in that case, what will be the flux through Gauss theorem, from the Gauss theorem? Q2, Q3 and Q6. So according to Gauss theorem, total flux is equal to Q2, Q2 plus Q3 plus Q6 divided by epsilon naught. Yes, Q6 will also be considered in this, because the surface is closed surface. So solution. The charges may be located anywhere inside the surface. If the surface is so chosen that there are some charges inside and some outside, the electric field on left side of the equation is due to the all charges, that is Q1, Q5 and this one, both inside and outside. So electric field is due to all charges, Q1, Q2, Q3 and Q4 and Q5. But E on LHS of the above equation, this one, Q divided by epsilon naught, will have a contribution from all charges, while Q on RHS will have contribution from Q2 and Q3 only, according to Gauss law. Total charge enclosed by the closed surface divided by epsilon naught. Now it is clear. Figure shows electric field lines in which electric dipole P is placed as shown. So there is an electric dipole. Which of the following statement is correct? Option A is the dipole will not experience any force. Option B, the dipole will experience a force towards right. Option C, the dipole will experience a force towards left. And option D, the dipole will experience a force towards upwards in upward direction. So which option is correct? Please think about it. Here, a electric dipole. You know what is electric dipole? A system of charges which consist two equivalent charges, two equal and opposite charges. So minus Q and plus Q. They are separated by small distance, that is 2a. So here our electric dipole is placed in electric field line, in the electric field. So our correct answer is C. The dipole will experience a force towards left. Solution. So thinking process is what? First, find the electric field strength on charges of dipole. Firstly, we will calculate electric field strength. Then force varies directly with electric field strength, that is, higher the electric field strength, greater the force, and vice versa. Higher the electric field strength, greater the force. So our answer is C. The space between the electric field lines is increasing. Look at here. Space between electric field lines is increasing. Here. This one. Here from left to right, and its characteristics states that strength of electric field decreases with increases space between the electric field lines. As a result, force on charges also decreases from left to right. So force is decreases. Thus force on charge minus Q is greater than force on charge plus Q. In turn, dipole will experience a force towards left. A point charge plus Q is placed at a distance d from an isolated conducting plane. The field at a point P on the other side of the plane is what? Given option. Option A is directed perpendicular to the plane and away from the plane. Option B, directed perpendicular to the plane but towards the plane. Option C, directed radially away from the point charge. And option D, directed radially towards the point charge. So which one is correct? Think about it. So our correct answer is A. Directed to perpendicular to plane and away from the plane. Solution. So when a positive charge, listen carefully, when a positive charge brought near an isolated conducting plane, some negative charge develops on the surface of the plane towards the charge and equal positive charge develops on opposite side of the plane. So in that case, this process is called charging by induction. Uh, so we have an example. Suppose we have a body. Clear? We have a body, and in this body, number of electrons is equal to number of protons. Means number of positive charge equal to number of negative charge. Suppose plus minus plus minus plus minus. Clear? Now an neg an a positive charge are brought near this conducting sphere. A positive charge Q brought near this conducting sphere, or we can say an plane. In that case, the charges are separated. So negative charge move towards the positive charge and LHS side, whereas positive charge in RHS side. Yes or no? So this is the charging by induction. Thus we get an electric field which is directed perpendicular to the plane and away from the plane. Clear? This question is for you. A hemisphere is uniformly charged positively. The electric field at a point on a diameter away from the center is directed in which direction? Given option. Option A is perpendicular to the diameter. Option B, parallel to the diameter. Option C, at an angle tilted towards the diameter. And option D, at an angle tilted away from the diameter. So which one is correct? Think about it. Which option is correct? So our correct answer is A, perpendicular to diameter. Solution. So when a point is situated at a point on diameter away from the center of hemisphere, charged uniformly positively, the electric field is perpendicular to diameter. It means what? So suppose we have a hemisphere. Listen carefully. We have a positively charged, uniformly positively charged hemisphere. Look at this. This one. Positively charged hemisphere. Yes or no? And this one is center. O. Now, here question asked about the direction of electric field. So due to this positively charged, the direction of electric field is perpendicular to this surface, like this. The electric field is perpendicular to the diameter. So this one is diameter. The component of electric field intensity, or we can say electric intensity, parallel to the diameter, cancel out. This is multiple choice questions, more than one options. Question is, if closed integration E dot ds is equal to 0 over a surface, in that case, option is the electric field inside the surface and on it is 0. Option B, the electric field inside the surface is necessarily uniform. Option C, the number of flux lines entering the surface must be equal to the number of flux lines leaving it. And option D, all charges must necessarily be outside of the surface. So which one is correct? So there is a more options may be correct. Think about it. So correct answer is C and D. C and D. Solution. First uh, we will learn thinking process. So go through Gauss's law in detail. So according to Gauss theorem, or we can say closed integration E dot ds is equal to 0 represents electric flux over the closed surface. This one, closed integration E dot ds. In general, closed integration E dot ds equal to 0 means the algebraic sum of flux entering the surface, algebraic sum of flux entering the surface and flux leaving the surface. So when closed integration E dot ds is equal to 0, it means flux entering the surface must be equal to flux leaving the surface. So in that case, what will be the flux? 0. Yes or no? Yes or no? Total number of entering flux or total number of leaving flux is equal. So next, now from Gauss's law, closed integration E dot ds is equal to total charge enclosed by the closed surface is equal to epsilon naught, where Q is a positively charge enclosed by the surface. So when closed integration E dot ds equal to 0, it means Q is equal to what? 0. So net charge enclosed by the surface must be 0. Therefore, all other charges must necessarily be outside of the surface. This is because of the fact that charge outside the surface do not contribute the electric flux because of flux formula. So total enclosed by the total charge total flux is equal to total charge enclosed by the closed surface divided by epsilon naught. So the flux is equal to this one. So the charges which is have outside of the surface do not contribute to the electric flux. Clear? Only depends on charges which is enclosed by the closed surface. The electric field at a point is what? Given options. Option A is always continuous. Option B, continuous if there is a no charge at that point. Option C, discontinuous only if there is a negative charge at that point. And option D, discontinuous if there is a charge at that point. So which one is correct? Think about it. Which option is correct? The electric field at a point is what? So correct answer is B and D. Solution. Here the electric field due to a charge Q at a point in a space is defined as the force per unit positive charge at that point. The electric field due to charge Q is first continuous at points where there is a no charge present. Second, discontinuous at points where there is a charge present. So therefore electric field is always continuous is incorrect because discontinuous exist at charge location. And second is electric field is discontinuous only at a negative charge is incorrect because discontinuous occur at any charge location regardless of sign. This is this question for you. Question is, if there were only one type of charge in universe, then Which option is correct? Option is closed integration E dot ds not equal to 0 on any surface. Option B, closed integration E dot ds is equal to 0 if the charge is outside the surface. Option C, closed integration E dot ds could not be defined. And option D, closed integration E dot ds is equal to q divided by epsilon naught if charges of magnitude q were inside the surface. So which one is correct? Please think about this question. Which option is correct? So correct option is B and D. Yes, B and D is correct. Solution. So even if there were only one type of charge in the universe, Gauss's law would still hold. So that is closed integration E dot ds is equal to q divided by epsilon naught. So let's analyze each option. So option B is correct. Because why option B correct? When the charge is outside the surface, listen carefully, when the charge is outside the surface, enclosed charge equal to 0. Yes or no? If the charge lies outside the sphere, in that case, total charge enclosed is 0. Therefore, closed integration E dot ds is equal to 0 divided by epsilon naught. So, what is the final answer? 0. Option D. Option D is correct as it's a direct statement from the Gauss's law. So according to Gauss's law, total flux is equal to total charge enclosed by the closed surface is equal to q divided by epsilon naught. So when charge is inside the surface, in that case, closed integration E dot ds is equal to q divided by epsilon naught. So B and D is correct. Clear? Yes or no? All right. Now, one important thing for you. According to Gauss theorem, flux is equal to this one. Total charge enclosed by the closed surface divided by epsilon naught. And one more formula, closed integration E dot ds is equal to phi. This one. So charge enclosed by epsilon naught is equal to phi and closed integration E dot ds is equal to phi. So number of electric field lines which passes from the closed surface represents the flux. Number of electric field lines passes from the closed surface represents the flux. Clear? So both the equation is correct. So it will become closed integration, this one, closed integration E dot ds is equal to q divided by epsilon naught. So B and D both are correct. Now, if you have any doubt related to electric charges and fields, please ask. If you have doubt, please ask the question. So one question for you. Suppose the electric field is equal to 4 Newton per coulomb, 4 Newton per coulomb, and radius of sphere is 2 meter. Radius of sphere is 2 meter. 2 meter. Then how much the number? How much the value? How much the value of flux? What is the value of phi? And here we consider angle is 0 degree. Find out the value of phi. What is the formula of this sphere? Area of this sphere. Formula of this. First we calculate the formula of this flux. Phi is equal to E dot ds. E dot ds. So resolving the dot product, you will be get E ds cos theta. Here theta is 0 degree. So it become E ds. So value of E is 4 and value of ds is what? 4 pi r square. So it become 4 into pi 22 divided by 7 into r square. It become 4. So 4 into 27 divided by 7 into 4. Please solve, and what is the answer? This is homework for you. Now, if you have any doubt, please ask. Two 201.142 Newton per coulomb per meter square. Okay. If you have any doubt, please ask. Now one question for you. So we have a this body, and charges is Q1, Q2, Q4 and Q5, Q6, Q7. Here, and Q1, Q1, Q3 and Q4. And you have to find out the flux. Phi is what? Where Q1 is equal to 2 microcoulomb, Q2 is equal to 3 microcoulomb, and Q3 is equal to Q1 Q3, this one is Q3, Q3 is equal to 3 microcoulomb, Q4 is equal to 4 microcoulomb, and Q5 is equal to 5 microcoulomb, and Q6 equal to Q7 is equal to 6 microcoulomb. So you have to find out the flux through this surface, surface S. We consider here surface is S. What is the value of phi? Please solve. What is the answer? Phi is equal to total charge enclosed by the closed surface divided by epsilon naught. So just substitute the value of Q and epsilon naught and find out the value of phi. This is easy question or not? Please answer. So Q1 plus Q3 plus Q4 divided by epsilon naught. This one. So just substitute and you will be get correct answer. Clear? This concept is clear or not? Okay. Have any doubt? Please ask. If you have any doubt, please ask. Any doubt from this concept, electric charges and fields? So here you have to find out the electric field. So here this Q5, Q6, Q7 lie outside of this boundary. So total charge is only this one. This is lies outside. This is outside. So according to flux, total flux Gauss theorem, total flux is total charge divided by epsilon naught. Q1, Q3 and Q4. So this is according to Gauss theorem. You know Gauss theorem, phi is equal to Q enclosed divided by epsilon naught. So Q enclosed is Q1, Q3, Q4 and epsilon naught. Clear? Yes or no? So the remaining options are A and C are wrong. A and C are wrong. Flux can be zero when no charge is enclosed, and electric flux as well defined from the Gauss's law, regardless of the charge type. So the type of charge, whether there is a one type or two, does not affect the mathematical formulation of Gauss's law. So it depends on total charge enclosed by the closed surface. Thank you for your attention.